All right, today's video we're going to do two quick examples on using integration by parts. So the first one is to integrate x squared sine x dx, and for this one we're going to let u equal x squared because then du is going to be 2x, and we're going to let dv be sine x dx. Because then when I integrate that, I get that v is going to be negative cosine of x. So then when I do my integration by parts, I'm going to get x squared times negative cosine, so negative x squared cosine x, and then minus a negative 2x cosine x, so I'm just going to make it positive because we got two negatives there, dx. And then we see that here, this integral, I need my dx's here. That's where it is. And then this integral, I'm going to use integration by parts again because I have the product of two functions where one is not the function of the other. So I'm going to let u equal 2x. So then du gives me 2. And then I'm going to let dv be cosine of x dx. So then v is going to be sine x. So then I still have that first term of negative x squared, and then I'm going to have negative x squared cosine x, plus, and then u times v of this, so 2x sine x, minus the integral of 2 times sine x dx. And then if I want to, but then I can look at this and I can see that, I can actually take that integral without integration by parts. So I get negative x squared cosine x plus 2x sine x plus 2 cosine x. And now that I've gotten rid of the integral, I need to make sure I have my plus c. So there is my final answer. Great. Our next example is finding the integral of secant cubed x dx. So this one is a little bit trickier. So I'm going to rewrite this as the integral of secant of x times secant squared x dx. And writing it like that helps me see that I'm going to actually do u as secant of x and dv as secant squared of x. I know it's not intuitive, but once you see it, hopefully you'll be able to kind of see this trick again. So if I let u equal secant of x, then du is going to equal secant x tan x dx. And I don't expect you to have that memorized. You can look that up on your cheat sheet, but eventually you probably will have it memorized because we are going to be doing a lot with secants and tangents. So it is helpful to know the derivatives and integrals of those. So then dv, I'm going to let be secant squared x dx. So then v is going to be tangent of x. All right, so now when I plug that into my formula for integration by parts, so I want the integral of u, so integration by parts, remember, we have uv minus the integral of v du. So I'm going to have secant x tan x minus the integral of secant x tan squared of x dx. And sometimes it's helpful when we go through our integrals to make sure that I have my integrals kind of all in the same trig function. That can be a helpful trick. So what I'm going to do is I'm going to use an identity here on tangent squared. So the identity I'm going to use is that tangent squared of x equals secant squared of x minus 1. So now my equation is secant x tan x minus the integral of secant x times secant squared minus 1 dx. And then I'm going to distribute. So I have secant x tan x minus secant cubed x minus secant x dx. then I'm going to separate those as two separate integrals. So I get secant x tan x minus the integral of secant cubed x dx plus, because I have a minus, secant x dx. And so what I notice here is if I look at what my original function was, I can pull this all the way down, this secant cubed, and we notice that I actually have an integral of secant cubed x dx on both sides. So I kind of went in circles, but not if I add that integral. So if I add that integral, and sorry if you hear my dog playing in the background, he is kind of in a hyper mood. So then I have 2 times the integral of secant cubed x dx equals secant x tan x plus the integral of secant x dx. And if I look at my little cheat sheet, I can see that I do have this integral. I have the formula for that. So now I have that 2 times the integral of secant cubed dx equals secant x tan x plus, and then this is going to be the natural log of the absolute value of secant of x plus tangent of x plus c. And then I can go through and divide everything by 2. I'll call it c sub 1. Divide everything by 2. So now I find that the integral of secant cubed of x dx, oops, I forgot my x in that previous step, is secant x tangent of x plus natural log of the absolute value of secant x plus tangent of x plus c, and then each of those are divided by 2 or multiplied by a half. And that would be our final answer right there. So definitely tricky. Not something I would expect you necessarily to be able to see and do on your own. But now that you've seen it, it's a trick that you can add to your toolkit.